Hi, so you should have just finished through problem number 4 on your day 4 worksheet. And I'm just going to kind of start with this so I can formalize the notes on average rates of change and instantaneous rates of change. So first of all, on number 4, you've been doing a lot of work with average rate of change. And this time they wanted you to actually find the slope between two arbitrary points, 3 and 3 plus h. So on the graph, if I were to draw the line in, I would be looking for the slope of this line. And if you know, average rates of change is just finding a slope. It's just the change in y over the change in x. So what you should have done is plug in the first y value. So you have 3 plus h because we're using 3 to 3 plus h. So this would be your interval. So you do f of 3 point h minus f of 3 all over 3 point plus h minus 3, and you simplified it. And your slope of this line should have been 6 plus h. That should have been your slope. And then you did the same thing. This time what you did is you went to a point to the left of 3. So first we'd had 3 and 3 plus h, so we went a little bit past it. And now we're going to find the slope of the line through 3 and 3 minus h. So you should have had a little bit different slope. You did the same exact calculations. So this time we were doing 3 and 3 minus h. And we ended up getting, the only difference is that the slope is 6 minus h. And so what you should have worked through is you should have saw that those are really similar. And it says, how close to 3 can you get? Well, we can get as close to 3 as we want, because our main goal, what we're working for or working towards, is trying to get the slope through 1 point, not 2. We're trying to get as close to 3 as we possibly can, or trying to get to that slope of the tangent line. Right now we have a secant line because we're going through 2 points. So we can get as close as we want. H can be 0.000001 or 0.00000001. We can get super close so that we're almost at 3. So it asks you, what is the average rate of change as the slope of the slope as it approaches 0? So if h is 0 here and h is 0 there, we're actually going to be just at that 1 point at x equals 3. We're actually going to get the tangent line. So you have a couple notes, and this is where I actually want to get into the notes. So if you want to take notes right in this document, I'm going to go ahead and copy this. We're going to start off with average rate of change, and scroll to the bottom of your note. And I have an example that we're going to be covering, so I'm going to paste this image here. I'm going to enlarge it a little bit. And so here's what the average rate of change is. It's the f of x plus h, so you just plug in your value here, x plus h minus f of x all over x plus h minus x. And you can see what's highlighted is what it simplifies into. So I'm going to draw a general picture because I think a picture helps a lot of people in seeing kind of what things are. Let's say you have this general curve. Let's say the curve does something like this. And you have x and you have x plus h. That's exactly what we're saying is what's the slope of the line on that interval. So we're going to go up to the graph at x, go up to the graph at x plus h, and then we're going to draw the line through those 2 points. The average rate of change, I'm going to try to do that again, not pick up my pencil. The average rate of change is just that slope of the line. So I'm going to put that. It's the slope of the line. And it's through x and x plus h. All right, so that's all the average rate of change is. It's just slope through 2 points. So let's just say we have this example. You can see the example that I have right here. Let's say I want you to find the average rate of change between 3 and 3 plus h. So kind of going back to that problem, but this time it's for the graph y equals x squared. So I'm going to go ahead and just do a little visual here so we have something. We all know what the graph of x squared looks like. It's just a parabola. And we want to find the slope of the line through 3 and 3 plus h. So h, again, could be like 0.1, 0.01, 0.0001. We're just going to try to get as close to it as we possibly can. So h, again, is arbitrary. So we're going to find the slope of this line. Let's see if I can do that. Okay. So that's going to be the average rate of change, how much it changes over that interval. So average rate of change is equal to f of x plus h, so it's going to be f of 3 plus h minus f of 3 all over x plus, or 3 plus h, because x is 3. So all over 3 plus h minus 3. So when I go ahead and simplify this, I'm going to get f of, and then our function is x squared. So I'm going to actually say that this is 3 plus h squared minus 3 squared all over, and then those 3's cancel, so I get h. So when I simplify and FOIL this whole thing out, I'm going to get 9 plus 6h plus h squared minus 9 all over h. So canceling out terms, my 9's cancel out, and I'm going to get 6 plus h squared all over h. No, I'm not. I'm going to get 6h, not 6 plus h. Let's try that again. And so then when I go ahead and simplify this, I can divide out this h in each of those. So my slope is 6 plus h. So this would be the slope, or the average rate of change for that line on the interval 3 to 3 plus h. Now, instantaneous rate of change is a little bit different. So here's the example we're going to use for this. Let's go ahead and go back to the top of the document, and let's grab for our notes so we have it all together. Let's add in these. Let me grab another part of that, but that's okay. So I'm going to copy and scroll to the bottom. Sorry if that's making you dizzy. Paste image. Yeah, I grabbed a little bit of the writing below, but that's okay. All right, so instantaneous rate of change. So what is the change or the slope at a particular instant? So here's the only difference between instantaneous rate of change and average rate of change. The formulas are identical all the way. I'm going to choose a different color here. All the way up to this piece. The only thing that it doesn't have is this limit piece. So I will say, let's choose a different color. This limit as h approaches 0 is the only thing that's different between these two formulas. That's the only difference. So remember how above when we had the two slopes as, I think it was 3 plus h, it was on number 4. Remember how, it was 6 plus h and we had 6 minus h. Remember how we said what happened as h approaches 0? What does the slope seem to get closer to? What's that slope of that tangent line? If h is 0, that means the slope of the tangent line is getting super close to 6. We're trying to narrow in on a slope around 3 and narrow it down to where that change is 0. So when we go back to here, let's use that same example. So what we'll have is, let's draw a picture too to kind of go with this before we go on to that example. So remember how I had that graph that kind of looked like this right above? This one right here. The only difference is that the instantaneous rate of change on the interval to x plus h is 0. So we're actually just finding the slope of the line. If h is 0, we're going to be finding the slope of the line at x that's basically tangent to the graph. So it gives you the slope. So I'll say IROC, instantaneous rate of change, gives you the slope at x. So at point x, since h is equal to 0. Okay, so you're actually just finding the slope through one point because we're making h 0. That's the only difference between AROC, average rate of change, and IROC, instantaneous rate of change. So we already did most of the work. We already found this whole piece of the formula above. We're still using x squared at x equals 3. The only difference is now on my parabola, we want to find just the slope of the line at 3. And so what we would do then is we know that that slope is 6 plus h. H now is going to be 0. So all we have to do to get the instantaneous rate of change is plug in 0. It's just the limit as h approaches 0 of the average rate of change. And we found out what that was. The limit as h approaches 0 of the average rate of change, which is 6 plus h from above, that is just going to give me 6. So the slope of that line, that at that particular instance is actually 6. So I just wanted to cover average rate of change, instantaneous rate of change, and kind of what they are. They're very similar. The only difference is that one, you're finding the slope at a particular instance, so h is 0, that's IROC, and one is where you're finding it through 2 points, and it's kind of an average rate of change, or the rate of change between 2 points. All right, that's a wrap. You guys can keep working on the worksheet, and you can go into the materials in Google Classroom if you have more questions.